the coordinator of the workshop, Dayashankarji, and he is in fact instrumental in organizing many workshops. Last month we had a workshop and there were many participants, but I think this time the number is less, but doesn't matter. Those who want to learn, they can appear anywhere in the world. So basically, let me tell you something about my area of research is biostatistics, and Shukla was talking about the geology, and the major component in geology is physiology, you see, and I have done a lot of work in the area of bioinformatics. Bioinformatics is a branch of basically which is integrating many you see subjects like computer science, statistics, mathematics, biology. So I know many of the terms of biology, and also my area of research, you know, is biostatistics. I am working into the area of cancer, ophthalmology, forensic science with a lot of doctors from one of the leading hospitals in the country, which is called PGI. PGI is called Postgraduate Institute of Medical Education and Research in Chandigarh. It is next to AIMS. The AIMS is at #1 in Delhi, and after that the name is PGI, where about you see OPD of 10,000 on an average, 10,000 people, they come to that hospital every day. So it's a very big hospital where collaborative projects and also some projects with ICMR, Indian Council of Medical Research, and also some projects with the WHO, World Health Organization. I was also doing my research with NIH. NIH is called National Institutes of Health in US, where I was a visiting professor for almost a year in 2014-15, and also to UK. I'm also the advisor to the International Medical Olympiad, which is there in Greece. So this is just a brief background from where I am. And if you have any problem at any stage, please don't hesitate. I will be discussing about 3-4 topics, very important topics, today and day after. One of them is called discriminant analysis, which is a multivariate technique. Another one is cluster analysis, which is again a multivariate technique. So these two techniques I will discuss today. And then tomorrow, I will discuss about the simple regression, then multiple regression, then also problems in multiple regression like multicollinearity and like autocorrelation. All these problems I will discuss tomorrow in the next session, which will be tomorrow on multiple regression. So let me start with the presentation. And this part today and tomorrow will be on R, and Sunday, the full session, those who are interested into SPSS. So I will discuss how to enter data in SPSS, how to import data into SPSS, and also how to carry out analysis in SPSS. So I will be discussing all the techniques on Sunday. So on SPSS. So let me start with the presentation. So I will share the screen. And okay. Just give me a moment. All right. Is my desktop visible now? Is the desktop visible?
Yes, sir.
Yes, sir.
Okay, very good. I mean, if anybody can respond in between, that will be helpful to me. Let me share the presentation. You see, you are already going through the package of R, how to install R, and how to read files from Excel or from some other package. So you have already done that part. I'm presuming that you have already done that part, because this discriminant analysis, cluster analysis, and multiple regression, which I will discuss today and tomorrow, they are the techniques where I am assuming that some of the basic tests are already clear to you, like t-test or the parametric or the non-parametric test. You know what is hypothesis and all these things. So I'll not focus on that because this part has already been taken by someone else. So before coming to the discriminant analysis, cluster analysis, and multiple regression analysis, I will discuss a little bit about unless or otherwise you are not familiar with the nature of the variables, it's difficult to do any type of statistical analysis. Particularly the nature of the data, any type of data, either it is called a structured data or it is called unstructured data. Now, what do you mean by structured data? Structured data is the one where the features can be easily extracted. For example, if I give you, let's say, height of 20 people, then you can easily compute its mean, you can compute its standard deviation, you can compute what is the minimum value, maximum value, what is the range of this data. So all these features can be easily extracted. So basically in structured data, the features can be easily extracted. Most of the time, the structured data is concerned with numeric form, like height, weight, blood pressure, cholesterol, where the features can be easily extracted. I can compute what is the mean age, what is the mod value of the age, what is the median age, and so on. So features can be easily extracted. What happens sometimes, the data is not exactly in the numeric form, but you can convert this data easily into numeric form. For example, let's say gender. Now, gender is not numeric as such, it's male and female. But I can easily convert this into numeric by assigning certain codes. Let's say male as 1, female as 2. All right. So it becomes numeric. Similarly, if you talk about religion, it's not numeric. It's Hindu, Muslim, Sikh, Christian. But I can always assign certain codes. Let's say Sikh has 1, Muslim has 2, Hindu has 3, Christian has 4. Or you can write Christian has 1, Muslim has 2, Hindu has 3. Does not make any difference. It is just you are converting your label to a numeric value. Similarly, socioeconomic class, as upper class, I can write 1 to 3. So that also comes under structured data. So what do you mean by structured data? If it is already in the numeric form, or you can easily convert any type of labels into numeric form, that also comes under structured data, where features can be easily extracted. For example, if it is gender, male and female, I can write male and female, and I can see male as 1, female as 2, and easily count how many times 1 has appeared, how many times 2 has appeared, right? So features can be easily extracted. 1 means how many males are there, 2 means how many females are there. So that comes under also the structured data. Then there is unstructured data. What is an unstructured data? Unstructured data is the one where features are not easy to extract. For example, everybody is using WhatsApp. You are receiving hundreds of SMSs every day, hundreds of SMSs. You are using email. You are going through the newspaper. You are reading in the research. Now, after going all through this, if I ask you that let's pick up the example of WhatsApp. Everybody is using WhatsApp. Suppose you have hundreds of SMSs every day, and at the end of 1 week, I ask you to convert the entire data into numeric form. I don't think it's easy because it is in the textual form. It cannot be easily convertible into numeric form. So this kind of data, where the features are not easily extractable, that kind of data is called basically the unstructured data. And people these days talk about the big data, and big data is nothing but a combination of structured and unstructured data. Of course, there is semi-structured data also, which is in fact covering both structured, and some part is structured, some part is unstructured. But basically, there are two broad topics. One is structured, another is unstructured. And big data is a combination of these two. Hopefully, this term is clear. What do you mean by structured data? What do you mean by unstructured data? If you have any doubt, please ask. Any doubt in this? Any question up to this? Or is it clear? Hello, anybody can respond, please? Anyone?
Sir, clear.
Okay.
Yes, sir, clear.
Okay, very good.
So, yes,
Now in this workshop, we will not talk about the unstructured data, because unstructured data, to handle unstructured data, we require some rigorous techniques, rigorous advanced techniques of multivariate data analysis. For example, you require the knowledge of Dirichlet's integral, then you require the knowledge of kernels and all these things, which are beyond the scope of this workshop. But two of my students from bioinformatics and two of my students from statistics, they have completed their PhD on unstructured data. Without reading the text, we can come to know what they are talking about without reading the text. So we have derived certain kind of such methods. Okay, but in this workshop, I will be talking about structured data. Structured data means which is in the numeric form. If you look at the structured data, it is basically of two types. Either it is called categorical data or it's called measurement data. What do you mean by categorical data? Categorical data is the one, I have already given you example, where the measurements are in terms of categories. For example, gender. Gender is just a category, male or female. I can write male as 1, female as 2. Socioeconomic class. It is just a category, lower class, middle class, upper class, 1, 2, 3, right? Or you can have only lower and upper, 1 and 2. It depends upon. So different colors can be coded, eye colors can be coded, skin colors can be coded. So all this type of data, which can be easily convertible into coded form or a numeric form, comes under what is called the categorical data. It is simply referring to certain kind of labels. And what is a measurement data? Measurement data means some kind of instrument is being involved in measuring something. For example, you can measure height, you can measure weight, blood pressure, cholesterol. So all this kind of data is a measurable kind of data. Okay, now we discuss about the structured data, which is either in the categorical form or in the measurement form. Now, this is the most important slide. Please try to understand, because this, whenever I will discuss about SPSS also, I need the knowledge of these scales, measurement scales. There are two scales which are concerned with the categorical data, and there are two other scales which are concerned with the measurement data. Now, what are the two scales for categorical data? One of them is called nominal scale, another is called ordinal scale. And other two scales for measurement data, one of them is called interval, another is ratio. All right. So first of all, I will just give you a brief idea about these scales, because unless or otherwise you are not familiar with these kind of scales, it's difficult to carry out any type of statistical analysis. So first two scales for categorical data, nominal and ordinal. Now, what do you mean by nominal scale? Nominal scale means you have category because it's a categorical data, but all the categories are given equal weightage. Bottom line is this. If all the categories are given equal weightage, then we say that our data belongs to the nominal scale. Or alternatively, you can say that there is no preference of one category over the other. If there is no preference of one category over the other, then we say that our data belongs to the nominal scale. Examples of nominal scale, like gender. Everybody is human being. I can write male as 1, female as 2, or you can write female as 1, male as 2. Doesn't make any difference. Similarly, religion. Everybody is human being. I can write Hindu as 1, Muslim as 2, Sikh as 3, or you can write Sikh as 1, Muslim as 2, Hindu as 3. Does not make any difference. Christian as 4, right? You can write in any order. So bottom line is, if all are at par, that means they are given the equal weightage, then we say that this type of categorical data belongs to the nominal scale. Then comes the ordinal scale. What do you mean by ordinal scale? In ordinal scale, it's again a categorical data, but the difference between nominal and ordinal is, in case of ordinal, you can arrange the categories either in ascending or descending order of magnitude. That's the only difference, which is not possible in nominal, right? For example, socioeconomic class. I can write lower class as 1, middle class as 2, upper class as 3. So 1 means the upper income group. So you can arrange the categories in order 1 to 3 or 3 to 1, right? Either in ascending or descending order of magnitude. Similarly, I am looking at the education categories, say primary school, middle school, then high school, graduate, postgraduate, and higher. So all these categories can be arranged in order from the highest. Primary means the lowest, post-graduation higher means the highest, right? So what is the difference between nominal and ordinal? The only thing is, in case of a nominal, all the categories are at equal level. They are given equal weightage. You cannot arrange them in order that this will come first or this will come later. You cannot do that. And in ordinal case, you can arrange the categories in order. That's the only difference. But important point to remember, whether your data is on nominal scale or it is on ordinal scale, the numerical distance, I'm just repeating, the numerical distance between any two categories does not have any significance. For example, if I'm writing male as 1, female as 2, and subtract 2 minus 1, do you think it has some meaning? It doesn't have any meaning. Let's say socioeconomic class, lower class has 1, middle class has 2, upper has 3, and subtract 3 minus 2. It doesn't have any meaning. So numerical distance, etc., does not make any sense whenever your data belongs to the nominal or ordinal scale. Remember this thing, right? So you have to be very careful whether your data is nominal or your data is ordinal. That's all about the categorical data. Whenever we are using this R package, nominal or ordinal data in R is generally called a factor. Somebody may have discussed. So whenever we talk about factor, that means we are referring to the nominal and ordinal as far as R is concerned. Then comes the measurement data. Measurement data is also having two scales. One of them is called the interval scale. Another is called the ratio scale. Now, what do you mean by interval? And people get confused between interval and ratio. I'll give you 2-3 examples to clarify. What do you mean by interval scale? Listen to me, please, carefully. In interval scale, sometimes the mathematical operations may not be valid. In interval scale, mathematical operations may not be valid. What does this mean? Let's say some beauty contest is going on, and there are judges say giving score out of 10. First person gets a score of 8 out of 10, and second one gets a score of 4 out of 10. So first person gets a score of 8 out of 10, second one gets a score of 4 out of 10. And if you divide 8 by 4, your answer will be 2. But you cannot make a statement that the person having score 8 is exactly the person having score 4. You cannot make such type of statement. Mathematically, it is not correct, right? So division, etc., does not make sense in interval scale. Similarly, I will give you another example. This was related to beauty. Let me give you a score example. Let's say some student has scored 90 marks in a test. Another student has scored 30 marks in a test. And if you divide 90 by 30, your answer will be 3. But I cannot make a statement that the student having score 90 is exactly 3 times the intelligent than the student having score 30. I cannot make such type of statement, right? So in interval scale, sometimes the mathematical operations are not valid. Remember this thing. And in interval scale, 0 is always taken as an arbitrary 0. It is not the true 0. For example, if somebody has scored 0 in a test, it does not mean the person is not intelligent at all. Maybe on a particular day, his or her performance is not up to the mark. Next time he or she can score better. You follow my point, hopefully, right? Let's say I say temperature 0. It does not mean the temperature is absent. It is still better than minus 10. So 0 means it has meaning. So whenever I talk about 0, that's why in 0 is called an arbitrary 0. That means something exists even at 0, right? And 0 has a meaning in interval scale. Hopefully the examples are clear. That's why 0 is called an arbitrary 0 in interval scale. All right. To overcome all such difficulties, there is a problem with nominal, problem with ordinal, problem with interval. We have a highest rating scale, and that is called the ratio scale, where all mathematical operations are valid. Let's say one person is having weight 90 kg. Another person is having weight 45 kg. If you divide 90 by 45, answer will be 2. But I can always make a statement that the person having weight 90 kg is double the weight of the person having weight 45 kg. Nothing wrong with that. Similarly, you can say that the age of the father is 3 times the age of the son. If father is 45 years, son is 15 years, so it's 3 times. So you can divide, you can multiply in ratio scale. But in ratio scale, 0 is taken as a true 0. For example, if I say height 0, basically it doesn't have any meaning. If I say age 0, it doesn't have any meaning. If I say weight 0, it doesn't have any meaning. So 0 is actually the true 0, while in interval scale 0 is an arbitrary 0. So anybody is not clear about the knowledge of these scales, any question they want to ask, they can ask me before I proceed further. Yes, please. Any question in these measurement scales?
Sir, may I ask one question?
Yes, please.
Sir, in case of nominal and ordinal, suppose if we have a problem and we have to compute some maybe effect of something on males and females, and we have the data for male and female. So whether there the gender will be treated as nominal or ordinal. I mean to say that there might be effect of some drug on. We have to compute whether the effect of that drug is going to have a greater impact on females than males. So
I understood your question. Listen to me, please. Whenever we talk about the nominal or ordinal variable or the interval ratio, we are only concerned with a single parameter, not the influence of this on other, not the influence on this, because its nomenclature may change, because male can have different particular that characteristic, female can have different characteristics, then altogether it's a different picture. So whenever we are talking about nominal ordinal interval ratio, we are referring to the single parameter at the same time, not combining the two. Remember this thing, please.
Okay, thank you.
Right? That will make it clear. Yes.
Yeah, it is clear.
And anybody else? All right, should I proceed further? Okay.
Yes, sir.
Now, people talk about these days about artificial intelligence, machine learning, deep learning, data science. And most of the time, people gets confused with these terminology. What do you mean by artificial machine learning or deep learning or the data science? So just to give you idea in 2 minutes, so that you should know, because to become a data scientist or to become a very good, let's say, interpreter or very good evaluator, you need to know these terminology. See, there is a bigger circle here. Bigger circle means this circle is referring to artificial intelligence. Enable machine to think. You have to train the machine to think. For example, whenever you are going to this withdrawal machine in the bank, right? You withdraw your money, ATM machine. So they have already trained the machine to think that whenever you feed, it will work on certain phenomena, and your 2,000 rupees will come out or 4,000 rupees will come out, right? So they enable the machine to think. So that is the role of the artificial intelligence. Then there is a machine learning, and in machine learning provides statistical tools to explore data. And there are 3 methods for basically, and it's an inner circle. It's an inner circle of the artificial intelligence, right? So what do you mean by inner circle? That means, first of all, you have to go, there is another inner circle, which is of deep learning, that I'll cover. So machine learning basically explores data. It explores data. That means it extracts features from the data, basically. So it is based on 3 types of approaches. One of them is called SML. SML is called supervised machine learning. And UML is called unsupervised machine learning. And this is called semi-supervised machine learning. So all these techniques are used in machine learning, right? Whenever we want to train the machine, so first of all, we have to go through the machine learning part before looking into the artificial intelligence. Then there is deep learning. For example, all the clustering procedures which we will learn today, that is a part of machine learning, basically. So it will cover the supervised learning, like past data, or maybe unsupervised learning, clustering or clustering techniques like hierarchical clustering, non-hierarchical clustering, DB scan clustering. So all these techniques will be used in machine learning, which I will discuss, particularly the phenomena of the cluster analysis today. Then there is another inner circle, and that is called a deep learning, and make machine to learn. Here we make machine. Here the tools and techniques are developed. Here the machines make machine to learn. That is a part of the deep learning. So if you are dealing with numbers, then that part of deep learning is called ANN. ANN is called artificial neural network. And if you're dealing with images, images means, let's say in a basket, I put oranges, I put apple, banana, I put grapes, all these things. And then you make the machine to learn, then identify how many oranges are there, how many apples are there, and all these things. That part basically in terms of image, or if there is a road, vehicles are going on, then you have to enable the machine to think, or enable the machine to learn whether it is a scooter or it is a bus or it is a truck or any other vehicle, right? Car or something like that. So whenever you are dealing with images, then we use what is called convolution neural network. And if you are dealing with the time series data means, which varies with time. For example, bank accounts varies with time, population varies with time, and so on. Then we use another part of deep learning, and that is called the recurrent neural network. So all this is a part of the deep learning. So deep learning comes first, then comes machine learning, then comes artificial intelligence, or data science. Then what is data science? Basically, it is an integrated part of this. So it covers some part of artificial, some part of machine learning, some part of deep learning. Along with that, you also have to go through techniques of statistics, probability, linear algebra, differential calculus, or other mathematics and statistical tools, right? So all these techniques are required for deep learning. So to be a data scientist, you have to be very good in programming, you have to be good in machine learning, you have to be good in deep learning, as well as probability, mathematics, statistics tools. Then you can become a data scientist. So I just want to explain you a little bit about all this terminology. So don't get confused, right? So these are simple terms. And because of this artificial intelligence, which includes, in fact, the deep learning, the machine learning, and the statistics and mathematical techniques. See, in Germany, 2,000 driverless cars are playing on the road. There is no driver, it's driverless, right? People just have to call, like just we call Uber and Ola. They call these cars, they will come to your place. Then you sit in the car, you feed your address, right? Where do you want to go? And they will take you from the shortest route. And if there is any conjunction or any, there is a speed problem, then they will take you from the shortest route, right? So 2000, in fact, last year in 2019, I was in Germany, in fact, and we have seen these driverless cars there. People are playing games sitting on the backside. People are going through the magazines sitting in the car. They don't have to drive. They're just sitting, right? Okay, now with this background, let me come to my first topic, which is called discriminant analysis. So we will be having break at 4:15 for 10 minutes, and then I'll come back from the second part, which is called cluster analysis. First of all, we will discuss about discriminant analysis. Now, why I have given you that background? Because you should know what do you mean by the nominal scale, ordinal scale, interval, ratio scale. So I will be talking about all these scales also here in discriminant analysis as well as in cluster analysis. Now, as the name suggests, discriminant analysis, that means how you can discriminate between two populations, how you can discriminate between more than two populations, and so on, right? For example, there are certain features where you can easily see whether it is a male or a female. Certain discriminating factors are there, like bias is there, like looks are there, right? So there are certain discriminating features. Basically, discriminant analysis is concerned with that. Try to understand. Discriminant analysis means how you can discriminate between the two groups or maybe more than two groups. So I'll give you one or two examples so that you can understand the basic idea of the discriminant analysis. Let's say I'm listening to a phone call. I can easily recognize the voice of male and female. 99.9% of the time you can recognize the voice of male and female. And if you look for male and female, let's say it's a male or a female, 99.9% of the time, maybe more than that sometimes, you can recognize whether it's a male or a female, right? So you can identify, and it's based on certain features, right? So that this is come into the picture. Okay. Now, what do you mean by discriminant analysis? I've just given you a very crude example of discriminant analysis, that we want to discriminate between two or more groups based on certain features. That is the idea of discriminant analysis. Now, discriminant analysis is a technique for analyzing data when the criteria of dependent variable is categorical. So in discriminant analysis, you must have gone through the regression analysis. In regression analysis, right, in R, you see, I will also cover tomorrow, there is a dependent variable, there are set of independent variables. But in discriminant analysis, whenever we talk about the dependent variable is always categorical. Now you know what do you mean by categorical data. If you're not aware of the categorical, that's why I discussed categorical data in the beginning and the measurement data. All right. So dependent variable like Y, and there are independent variables like X1, X2, Xk. So in discriminant analysis, the dependent variable is always categorical. Dependent variable is always categorical in nature. That means it could be male and female like 1 and 2. It could be present or absent like 1 and 0. Or it could be any other feature which can be categorized into two categories. All right. So it's a categorical variable. But what about the independent variables? There are independent variable means features. Features means X1, X2, Xk. Remember, in discriminant analysis, all the features, they have to be measurable quantities. They cannot be categorical. Making a very strong statement. In discriminant analysis, all the independent variables, they have to be measurable quantities. They cannot be categorical. Only dependent is categorical. Only dependent is categorical. And independent variables are also called predictors, right? And all predictors, they have to be in interval or the measurement scale. Remember that, interval or the ratio scale. So discriminant analysis is a technique for analyzing data when the dependent variable is categorical and the predictor or independent variables are interval in nature, interval or ratio scale. So objectives of the discriminant analysis are as follows. What are the objectives of the discriminant analysis? So development of a discriminant function. We develop a discriminant function. What is a discriminant function? It is a linear combination of variables. Now, what is a linear combination? For example, there are two variables. Say there is a variable x1, there is a variable x2. Then its linear combination can be written as L. L is equal to, let's say, a1 x1, where small a1 x1 plus small a2 x2, where a1 and a2, they are just some constants. Most of the time in discriminant analysis, their values will be between 0 and 1, right? And in factor analysis also, well, their values are between 0 and 1. So sometimes these are called weights also. And in discriminant analysis, they can take any value. A1 and A2 can take any value, but in factor analysis, their values are between 0 and 1. So in discriminant analysis, it's look for the linear combination of independent variables. And this linear combination can best discriminate between one group to another. So I will discuss about all this. So basically, we have to develop a discriminant function. So examination of whether the significant differences exist among the groups or not. Then determination of which predictors. Let's say you have 15 predictors or 15 independent variables. Whether all the 15 are important or only 6, 7 are important. So it will identify that also, that only these are important to discriminate between this and this, right? Then classification of the cases too. So discriminant analysis is not a prediction technique. Remember, please. Discriminant analysis is not a prediction technique. It is a classification technique. It's a classification. You need to classify whether this individual belongs to this group or it belongs to this group. So it's a classification technique. It's not a prediction technique. Prediction techniques like regression techniques are prediction techniques. Logistic regression is a prediction technique. And people get confused between discriminant analysis and logistic regression. So remember, logistic regression is a prediction technique. Discriminant analysis is a classification technique. Similarly, cluster analysis is a classification technique. It is not a prediction technique. Okay. Then we have to find out how many observations have been correctly classified. So we will go through all this procedure of discriminant analysis. Now I'll take up one example to make it clear what do you mean by discriminant analysis. You see, after 10+2 in India, either people go for professional courses. Professional courses means like engineering or medical or MBAs or law. All these are professional courses, right? Or they opt for non-professional courses. Non-professional courses means doing some BA, MA course as routine, either in political science, sociology, mathematics, statistics, all this. They are non-professional courses up to certain level. Of course, you can become professional in any field, but initially after 10+2, either people go for professional courses or they opt for non-professional courses. All right. Now, question is how to distinguish between professional and non-professional. What are the features? What are the features that people will go for professional courses? What are the features that the people will opt for non-professional courses? And these psychologists, they are very smart. They study many different kind of variables like personality variables, skill variables, communication variables, convolution, mental age, IQ, right? They study very different type of variables, and they can discriminate that this person is likely to go for professional and this person is likely to go for non-professional, right? Let's say they study some variables, and these are the variables x1, x2, x3, and xk. So they are all independent variable, but they are measurable quantities. And this is your dependent variable. Professional means you can call this as 1, non-professional you can call this as 2. So either professional is 1 or it is 2. That's a categorical variable. So this is your dependent variable and this is an independent variable. And based on this dependent and independent variable, so which one is categorical? This one is categorical, which is a dependent requirement of discriminant analysis. Which predictors have to be measurable quantities? X1, mental age. X2, IQ, again measurable quantity. X3, maybe skill, some skill score, personality score, something like that, right? Now, based on this data, we develop a score, and that function, we develop a function basically, and that function is called discriminant score function. That function is called discriminant score function, and it will look like this. So DS, this is called discriminant score, and we call this as discriminant score function, right? And it will be a linear combination of these variables. This linear combination means there will be some constant term, b1 x1 plus b2 x2 plus b3 x3 plus bk xk. There are k independent variables, and there will be some discriminant function which will be formed on the basis of the linear combination of these variables. Linear combination of these variables. And you will get basically the discriminant score, right? Now, based on your data, it will also compute two different centroids. One centroid is called C1, another centroid is called C2. This C1 will be for professional and this C2 will be for non-professional, right? Now, I will get this equation actually, where this will be known to me, B1 will be known to you, B1, B0, B1, B2, they are known to me from the given data. So you can compute all these unknown coefficients. Now, once these are unknown, and now a person has approached to a psychologist and he is asking, Madam, should I go for professional courses or should I opt for non-professional courses? And this psychologist, they looked into the IQ of the person, personality score, communication score, and all this, and put into this equation. Now, these constants are known to you. They are known to you. And x1, x2 from that person, they are known to you. So you will get, substituting all the values, you will get ds, value of ds. That is called discriminant score. And then this psychologist see whether this person's discriminant score is closer to professional. If it is closer to professional, he will ask that you should go for professional courses. And if it is closer to the centroid of the non-professional, then he asks them you should go for non-professional courses. Hopefully the problem is clear, that we want to discriminate those important features which can discriminate between professional and non-professional. So that is the idea of going for discriminant analysis. Hopefully with this example, I think idea is clear, and then we will do this in R. Okay. Now there are certain similarities between analysis of variance, which you have learned, I think, regression, simple or multiple regression, and discriminant analysis. So here I have written ANOVA, one-way ANOVA, two-way ANOVA. Here it is a regression, and here is a discriminant analysis. So there are certain similarities and dissimilarities. What are the similarities, first of all, in all the three? In all the three. So if you look at ANOVA, if you look at regression, if you look at discriminant analysis, the number of independent variables, sorry, number of dependent variable is in ANOVA it is 1, in regression it is 1, in discriminant analysis or again 1. Number of independent variables in ANOVA it could be multiple, in regression it could be multiple, in discriminant analysis it could be multiple. For example, in our case it is x1, x2, xk, right? Similarly, in regression analysis, it could be x1, x2, xk. In ANOVA also, it could be alpha I plus beta j plus eij. But the only thing is it could be multiple, but they have to be factor. That's all. Otherwise, they are multiple. So these two are similarities. What are dissimilarities? Dissimilarity is in ANOVA, the dependent variable is always a measurable quantity. Dependent variable is always a measurable quantity, right? In regression also the dependent variable is measurable, which is called metric. But I have already explained you in discriminant analysis, the dependent variable is a categorical. So there is a dissimilarity here, right? Then number of independent variables. In ANOVA, number of independent variables are always categorical, like alpha I plus beta j. In regression, they all have to be measurable quantities, metric variables. And in discriminant also they have to be measurable quantities. So these are the similarities and dissimilarities between all the three, ANOVA, regression, and discriminant analysis. Please remember this. Okay. So there are certain terminology to be understand before I apply discriminant analysis. See, whenever there is a dependent variable is having only two categories. If your dependent variable is having only two categories, then this is called two-group discriminant analysis. Then it is called two-group discriminant analysis. But if your dependent variable is having more than two categories, then this is called multiple discriminant analysis. For example, it could be lower class, middle class, upper class. So these are three, these are not two, right? Then in that case, if your dependent variable is having three categories, then this will be called multiple discriminant analysis. If it is just present or absent, or male or female, then it is called two-group discriminant analysis, right? Okay. Now, main distinction in two-group is to drive, in case of if dependent variable is having only two categories, then you can drive only one discriminant function. You can describe only one discriminant function. What is a discriminant function? This is called discriminant function. So if you are like 10 plus 2 professional or non-professional, you will get only one discriminant function. But suppose there is a third category also in between, semi-professional, suppose semi-professional, non-professional, professional, and semi-professional. Then there could be more than two discriminant functions. I can call that as DS1, another will be DS2, right? So how many discriminant functions we can draw? It depends upon how many groups we want to classify, right? If there are G number of groups, then your discriminant score or the discriminant functions will be G minus 1 or K, whichever is smaller. K is then how many explanatory variables or independent variables you are taking into your model. But generally we look at G minus 1. So that means if there are three categories, there will be two discriminant functions. If there are four categories, there will be three discriminant functions, right? That is the idea. Okay. The first function explains the highest variation present in the data basically. And the first function has the highest ratio of between groups to within group sum of squares, right? Then, I mean, it can best discriminate. The first function always best discriminate between the two groups. The second function, which is uncorrelated with the first one, has the second highest ratio of between to within. And we continue like this. So in discriminant analysis, basically you will get this discriminant score. Then there are two centroids. You compute for any individual and you want to classify that particular individual, whether it will go to professional or non-professional. So you compute this value D, and if D is closer to C1, he will go for professional. If D is closer to C2, he will go for non-professional, right? So this is called discriminant score. BIs are called discriminant coefficients or weights, and these are called predictor variables. X are predictor variables, right? Now, how these coefficients are estimated? These coefficients, we estimate these coefficients like B0, B1, B2 from the given data based on that the ratio of between group sum of squares to within group sum of squares is at maximum. This is how they are estimated based on maximum likelihood technique, basically. So it's based on maximum likelihood technique. Okay, there are certain statistics which are associated with the discriminant analysis. One of them is called canonical correlation. Now, what do you mean by canonical correlation? Canonical correlation is nothing but the correlation between the discriminant score and the factor or the groups. Discriminant score and the groups is basically called canonical correlation. And centroid, I have already given you the idea of centroid, that for each group, different centroid. If there are three groups, three centroids will be there. If there are two groups, then two centroids like C1 and C2 will appear. Then there will be a classification matrix. Classification matrix is basically sometimes also called confusion matrix or prediction matrix. It will classify, see, you have the actual value initially. For example, whether it is a male or female, initial data is there, and they have been discriminated based on certain features like X1, X2, Xk. Then you have developed your equation, which is called discriminant score function, right? So one value you actually know that it is male, it is female, and one is based on the prediction of your model. So it will match the two, the actual value and the predicted value. If they are hand to hand, your prediction is very good, but there may be some misclassification, and this classification matrix is basically concerning with misclassification. How many cases have been correctly classified according to the model and according to the actual data? How many have been correctly classified and how many have been misclassified, right? Okay. Certain other features to discriminant function coefficients like B0, B1, etc. They have to be estimated from the given data. And whenever they are multiplied with X1, X2, Xk, you will get discriminant score. Then one important feature will appear, that is called eigenvalue. It will appear whenever we do the analysis for each discriminant function. Let's say I draw, if there are only two categories, I'll get one discriminant function. So there will be one eigenvalue. For one discriminant function, there will be one eigenvalue. All right. So for each discriminant function, the eigenvalue is the ratio of between group to within group sum of squares. Larger the eigenvalue, superior is the function. Larger. So you have to see how much larger is your eigenvalue. If eigenvalue is very large, they can discriminate. Clear indication that these variables can discriminate between the groups. Okay. Another is with the help of F values, you can get idea. Suppose you have 10 variables, X1, X2, X10, right? Then for each X1, F will be computed. For X2, F will be computed. For X10, F will be computed. And it will initially give you idea whether X1 is important to discriminate between the groups, whether X2 is important to discriminate. If it is coming out to be, if F value is coming out to be significant, that means this variable is important to discriminate. If it is non-significant, this variable is not important to discriminate. You can leave that also, right? Then you will also get group means and group standard deviation for each group. Then pooled within group correlation matrix will be there, that will appear. And sometimes we also get the standardized discriminant function coefficients. There is a discriminant function coefficients. These are unstandardized. What are standardized? You subtract the mean, divide by the standard deviation, you will get standardized discriminant functions. Now, where we use this? Let's say your one variable is measured on 5-point scale. Another variable is measured on 7-point scale, right? So in that case, before even applying the discriminant analysis, we need a standardization. So we standardize both the variables x1 and x2 by subtracting mean divided by the standard deviation, so that come to the same level. And then we go for discriminant analysis. Then you will also get structure correlation, which is nothing but correlation between the discriminant loadings, or the structure correlation represents the simple correlation between predictors and the discriminant functions, right? Then you will get very important feature, which is called Wilks lambda. And Wilks lambda values lies between 0 and 1. It is nothing but within group sum of squares to the total sum of squares. And smaller the value of Wilks lambda, the greater is the discrimination. Let me just repeat, smaller the value of Wilks lambda, greater is the discrimination. So with this Wilks lambda value, it is associated with p-value. Its value has to be significant. If Wilks lambda value is significant, that means you can go ahead with the discriminant analysis. The most important part. It is basically a test of discriminant analysis. Can we apply discriminant analysis to this data or not? Look at Wilks lambda. Wilks lambda value has to be significant, right? Okay. So we will apply discriminant analysis to this type of data. I'm just showing you the data, and then we'll go for R. And in 15-20 minutes, we will be able to complete discriminant analysis by using R. People go to resort visit during holidays. You see, in June, July, whenever there are holidays, people go for resort visit. That we will go to Andaman Nicobar, or we'll visit some other place, Kulu Manali or Shimla in vacations. So either they will go for vacation or they don't go for vacations. So going for vacation or not going for vacation depends upon different factors, right? What are different factors? Let's say, yeah, resort visit, if they are going, let's say 1. If they are not going, then it's a next slide. Next slide means 2. You see, 2 means they are not going. 1 means they are going. Now resort visit, so it's a you can say categorical variable. So this is a dependent variable, whether people will go for resort visit or they will not go for this resort visit. Now it depends upon many factors. It depends upon the annual family income. So this is the annual family income. It also depends upon attitudes towards travel. Some people even are having money, but they don't want to travel. Their attitude is important, right? So it is measured on 9-point scale. It is measured on 9-point scale. Then importance attached to the family vacation, how important it is, again on a 9.9-point scale, right? Household size, whether they are having smaller house or they have larger house, and age of the head of the household. I'll not take this into picture. This is the third variable, amount spent on family vacations. Okay, right? So that means this is your dependent variable, which is a categorical variable, either 1 or 2. 1 means they will go for resort visit. 2 means they will not. Annual family income, it depends upon x1. This is your x1. This is your x2, x3, x4, x5. So there are 5 predictor variables. And we want to discriminate whether these 5 can discriminate whether people will go for resort visit or they will not. And out of this 5, which one is most important? Which one is next important, right? To discriminate between people will opt for a resort visit or not to opt for a resort visit. So this is a problem of discriminant analysis. Now this is the theoretical part. If you have any question in theoretical part, please. Now I'll move on to practical part.
So I have one question.
Yes, please. Yes, please.
So what if this variable attitude toward travel, what if it has 2 questions in it?
Means?
So items.
No.
अगर हमने if question आया fill कराया and we have asked 2 questions related to this variable.
You combine both the questions, come out with 1.
So how will you combine it?
Generally, attitude question, if you ask a psychologist, it is only 1. But sometimes relating to attitude, there may be 5 questions even, right? They are all related to attitude.
Yes,
then you take the sum of all the 5. It will generate another variable, and that will be, you take that variable into here in discrimination. Yeah.
So we have to take sum, not everything.
Sum of this.
Okay.
Yes.
Okay. Thank you.
Yes, please. Any other question? Very important question she has asked. Any other? Is the technique clear? What do you mean by discriminant analysis? Hello, is the technique clear?
Yes, sir. Yes, sir.
Yeah, okay. Now I'll
Sir,
go for the
may I
practical.
ask one question?
Yeah, please carry on.
Sir,
Ask,
number
please.
means the number of samples. The
Number means
here.
which
Does
number?
it
Which
mean
number
the
you are
number of
talking?
samples?
Which
The
which
first
number you
column.
are? Number. Oh, sorry. This is just a serial number. How many people are there? For example, in 15 people, they are opting for those who want to go for resort visit. That is put as 111. And then there is next slide 222. That means again next 15 are there which are not opting for resort.
Okay. So number here is just the serial number. It is
Sample
not
size,
the
basically.
sample size or something.
Yeah, it's a
Okay.
sample size.
Okay.
Okay. Yes, please. Any other question?
Okay.
Any other question? Any other question?
No, sir.
Okay. All right. Let's go for practical part. So I'll be opening, you see, whenever we want to start any analysis using R or SPSS, it's better to open a folder. So I have made one folder here with the name as Shanti2. Because last month I have delivered a talk, I made a folder Shanti1. Now I am calling this as Shanti2. Okay. So this is the name of my folder. Any file which is used for analysis, you can put in this folder. First of all, that is your aim before starting with R, right? And then you have to set your working directory. You see, these are the files which are already there in R. It is just a history. I'll just delete this part. So these are all the files which I'll be using today and tomorrow. Okay. So remember, our file directory name is Shanti2. Okay. Now I'll be opening this R Studio and we will do the analysis for discriminant analysis. Just using, sorry, this is R. I have to open R Studio. I'll open R Studio. This is R Studio. You can work the same thing in R, doesn't matter, but R Studio is easy. Okay. See, what is our folder's name? Shanti2, you remember, right? So first of all, you have to move into your folder. So either you can use, I think somebody you must have teach you that how to set working directory, get into the working directory. I'll not repeat those parts, right? So for example, set working directory. Our working directory is Shanti2. So either you can use / / or you can use symbol /. So this is the first option. Second option, you can use any one of them. So let me go to my folder first of all, run this. So this is run button. So it has come to this. Or you can use the second one, you will get the same thing. And get working directory, whether you are into your folder or not. So let's get working directory. So it says now you're into the directory of users, air, and Shanti2. Here we are. That means we are connected to now our own directory. This is what it means, right? Now in R, if you remember, we know, you know how to create vectors, you know how to create data frames, right? Since one part of my topic is basics of statistics. So I'll in just 4 or 5 minutes, I'll cover the basics. You know how to create vectors. So this is how to create a vector. For example, vector of some observations. I have written just with comma, and C. C means this is called concatenate. That means if you want to write down more than 2 observations, then we use C. You remember this thing, right? So this is C. So these are the values. X means how many values are there? You see, this is 2, 3, 4. All the values will be printed. Length means how many observations are there. So it will give you the length. 10 observations we are dealing with. If you want to compute sum, so it will give you get sum. So sum of all the observation, if you add them, you will get 60. If you see 61 divided by 10, your answer will be 6.1, and that will give you the mean. And if you want to compute mean, you see 6.1. Similarly, the minimum value is 2 here. You can see minimum value is 2. Maximum value is 10 here, and range will be 2 to 10. You can see 2 is the minimum number, and this. Similarly, you can compute median of this. You can also go for the standard deviation of this data, the vector which you have, then variance of this data. Square the standard deviation, you will get variance. Then different quantiles you can compute or percentiles. So you will get 0th, 25th percentile, 50th percentile, 75th percentile, and 100th. What does this mean? This means basically 25th percentile means what? That means 25% of the observations are below this point, 4.25. If I take cutoff as 4.25, then 25% of the observations will be below this point, right? Similarly, 7.75 means 75%, means 75% of the observations, that means out of 10, 75% of the observation will be below this point, which is 7.75. This is what it means, right? Similarly, summary can give you the entire statistics. What is the minimum value? What is the maximum value? The first quartile of the data, the median, mean, third quartile, right? You can go for sorting also. Sort means from the lowest to the highest, and reverse sort means sorting in the reverse order. So this is the reverse sort, highest to the smallest, right? Similarly, we can compute skewness, kurtosis for any vector, and in order to compute skewness and kurtosis, we need to install this package, which is called moments. So installing of the package install, you can go from here. You see, packages are all here, or you can simply write down this command. If it is already here, moments, let's say if this package is already here, you can just click onto that package. You can just click onto that package, right? And if it is not in the list, then you can use this command, which is called install.packages, and in quotes moments, install.packages moments, right? Suppose I install, so it will start installing. So it has installing now. It is installing. If it is already here, you just click. It will automatically install. It will be automatically installed, right? There is nothing to do. Otherwise, you have to write down this. Then now package has been installed, but it has not gone to the library of R. You have to take this to the library of R for further analysis. So always use library without quotes. Whenever we install package, we write down with quotes. And whenever we take to the library, it is without quotes. Remember, please. So this is without quotes. Now it has gone to the library. Let's say I feed this vector, which is again X. All the values are here. And I want to compute skewness and kurtosis. So this is the skewness of this data. This is the kurtosis of this data. And you can go for the corrections of the data. So let's say I enter this X here. Suppose I enter. And I want to modify. Suppose I want to replace, this value, which is, suppose 7 with 17. Right? 7 with 17. Then what to do? You data.entry X, that I want to make corrections in S. So run this and you will come to this editor. And I want to replace 7 with 17. You can replace straight away. Replace this 17, right? And close from here. And if you close from here and run it again, now you can see instead of 7, you have 17. It has changed. So if you want to change any value, you can change. These are called editing commands. Data entry X, right? Similarly, in generating functions, we can generate different type of functions. So let's say I want to generate numbers from 1 to 10. So 1 to 10 means you can use C 1 colon 10. 1 colon 10 means it will give you a sequence of 1 to 10. So print x1, so it is a sequence of 1 to 10. If I want to get a sequence between 23 to 45 numbers, so you can use between 23 and this, and you will see put x1, you will get another between 23 to 45. Or we can sometimes either you make use of this, or you can make use of this. They will give you the similar results without even C. Let me try this one. You see x1, you are again getting the same thing, right? And if you want numbers to be less, first numbers between 1 to 5, then 20 to 25, then 50 to 57, you can use this command. You can see and get the print, and you will see first numbers are between 1 to 5, then it will start from 20 to 25, then it will start from 50 to 57, right? Then this is all I have given you, just preliminary analysis. And then you can also go for the data frames. You know how to I think Professor Atali Khan, he is very good in R. He has already explained you how to make this data frame. Data frame means it's basically joining the columns together. It's form a type of a matrix basically. So let's say I have a length, means height. I have a weight. I have the name of the person. So 3 vectors I generated. One is for length, another is for weight, another is for name. And based on this, I want to generate a data frame with the name first, then. So let's call this as friends. They are my friends. Let's say Anil, Ankit, and Sunil. So call this as friends. Data.frame. This is the command to be used. Data.frame. So which one you want first? Let's say name first. Then comes length. Then comes weight. So if I put weight first, then weight will appear first. It's your choice. So I run, and friends, now all this is in one file. First column of that file will be name, second will be length, third will be weight, and you can see that. You see, first one is name, second one is length, and the third one is weight. Right. Okay. I think we can have 10 minutes of break, and then I'll come back. Dayanand ji.
Ji sir, no problem.
Can we have 10 minutes? Come back?
Yes, sir.
I request all the participants, if you have any questions, please. I mean, you can come up with your questions also, and we will do the discriminant analysis. Once you are clear with basic functions of R, then the discriminant analysis is just a simple code, right? And you can apply discriminant. I'll send you this file so you can practice. 10 minutes of break, and then I'll come back. Please have a cup of tea or something in 10 minutes, but don't take more than 10 minutes. I'll also be back in 10 minutes. And if you have any question, you can ask me right now. If you have any question, please. Any question? Any question, any participants want to ask? So if there is no question, I'll be back in 6-7 minutes. I'll be back in 6-7 minutes. And
Okay.
do not switch off your, yeah, okay. Now I am back. If anybody want to ask questions, please, in the meantime. Anybody want to ask question? Any question about discriminant analysis or whatever I have explained? Yes, please. Any participant? Madam Shukla, any question? Or anybody?
No.
Ji.
No, sir, not from my side. I'm
Okay.
understanding everything. I just wanted to say that you have explained everything in such a lucid way that a layman not having any background of statistics can understand that so nicely.
Thank you very much. Yes, Krishna.
सर मैं कोई क्वेश्चन तो नहीं पूछना चाहता, लेकिन सर जब मैं इसे प्रैक्टिकली रूप पे अप्लाई करूंगा सर, तो सर जब दिक्कतें आएंगी तो उस समय के लिए कुछ आपसे
उस टाइम में मैं आपको फाइल भेज रहा हूँ ना, ये फाइल भेज रहा हूँ, इसमें सारे कोड लिखे हुए हैं, उसको प्रैक्टिस करिए। ओके सर, मैं फाइल कल भेज दूंगा आपको।
यस सर।
हाँ, तो आपको वो दिक्कत नहीं आएगी।
यस सर।
यस प्लीज। एनी अदर क्वेश्चन? और भी कोई क्वेश्चन किसी के माइंड में कुछ भी आ रहा है? चलिए, जो टॉपिक नहीं भी पढ़ाया, अगर उससे भी रिलेटेड कुछ और आ रहा है तो वो भी पूछ सकते हैं आप। स्टैटिस्टिक्स में कुछ भी, जो भी आप पूछना चाहते हैं। चलिए, लग नहीं रहा कुछ।
सर कुछ ला दीजिए चाय के। मैं तो इसीलिए बैठा हूँ सर।
अच्छा, देखो दया शंकर जी को ना शेर सुनने का बहुत शौक है, और मैं शेर लिखता रहता हूँ कि इंसान की सोच पे ही सारा कुछ डिपेंड है। क्यों दया शंकर जी? सब कुछ सोचता ही है ना इंसान।
जी सर।
तो दो चीजें इंपॉर्टेंट है लाइफ में, एक तो इंसान की सोच और दूसरी चीज उसकी डायरेक्शन कौन सी है, क्योंकि सोच के अकॉर्डिंगली डायरेक्शन बनती है। तो उसी पे एक शेर है कि सोच को बदलो सितारे बदल जाएंगे, सोच को बदलो सितारे बदल जाएंगे, नजर को बदलो नजारे बदल जाएंगे, कश्तियों को बदलने की जरूरत नहीं, दिशा को बदलो किनारे बदल जाएंगे।
बस सर।
जी,
वेरी ग्रेट।
और
सुपर्ब सर
जी। चलिए, हम तो कोशिश करते हैं कि मतलब कि भाई सारी चीज समझ आ जाए और सिंपल वे में समझ आ जाए। मैं बहुत कोशिश यही होती है कि सिंपल तरीके से समझाया जाए, ताकि हर आदमी जो जिसको स्टैटिस्टिक्स नहीं भी आती वो भी समझ सके। जी
सर, मुझे तो कम से कम आ रही है, क्योंकि स्टैटिस्टिक्स में मैंने 100 में 0 कलेक्ट किया था।
कोई बात नहीं, आज के बाद आपका ना हम
किसी के पास नहीं है।
अच्छा, नहीं कोई बात नहीं, उसके आगे हम ऐसा करेंगे कि एक 1 लिखेंगे और पीछे 0 और लगाएंगे ताकि 100 हो जाए।
जी सर, लेकिन कम से कम अब तो समझ में आ गया।
चलिए, अच्छी बात है।
ग्रेट
जी, वो तो अच्छी बात है कि ये तो आपका बड़प्पन है। वो कहते हैं ना कि माना की हालातों से इंसान बदलते हैं, माना की हालातों से यानी सरकमस्टांसिस से आदमी बदल जाता है। माना की हालातों से इंसान बदलते हैं, पर हालात भी हम इंसान बदल सकते हैं।
वाह सर, वाह।
सरकमस्टांसिस भी आदमी चेंज करता है और कोई नहीं चेंज करता।
जी सर।
जी, चलिए, गुड। चलिए सर, शुरू करूं फिर मैं? मेरे ख्याल से 10 मिनट हो गए।
जी सर।
ओके, so let me come back to the presentation now. So we were here. How to import the file, how to import the Excel file, and generally we in R or RStudio we import CSV file. So if there is an Excel file, we convert this to CSV, and CSV file can be easily imported into R or RStudio, right? Now this is the one way, because if your file is already in your directory, then you will not have to define any path. Remember, since we are already into our own directory, which is Shanti2, and there is a file which is called test1. So test1 file is already there. So I'll not have to define any path now. So what is the command of CSV? data. Let's say I want to get this entire file into a data frame, which is this will become data frame, which is called data, right? So command is very simple, read.csv, and just give the file name in quotes. So my file name is test1.csv. So I run this. So file is already there without any error, right? And if you want to see what kind of structure it has, so it's a data frame. You see data frame with 70 observation and 5 variables. What are those 5 variables? First is mutation, because this data is related to genetic constitution, whether the genes is having mutated or not mutated. Then age is there. Then locality is there. Locality means rural as 1 and 2 as urban. Gender is there. 1 is for male and 2 is for female. Then religion. 3 types of religion are there: Hindu, Muslim. I think Sikh is there. Maybe Christian is there. I don't remember. But anyhow, if you want to view the data, then there is a command. Please remember, when we view the data, this is capital V in R. If you write small v, it will not work, because R is case sensitive. You remember, R is case sensitive. You have to be very careful. So in view data, V is capital. So you run this and you will see this entire file with 5 variables. This is first variable, mutation, then age, locality, sex, religion, and you can see the entire file if you scroll through, right? 70 observations. This is what the description is here, that there are 70 observation, 5 variables. 1, 2, 3, 4, 5 variables. So 70. All right. So just closing this data. Now you have viewed the data. That's this data is. Now how many of this are categorical? For example, mutation is categorical, but age is not categorical. It's a continuous measurement. Locality is categorical. Sex is categorical. Religion is categorical. So out of the 5, 4 are categorical, while 1 is measurement variable, right? Hopefully you understood this part. What do you mean by measurable quantity? What do you mean by categorical variable now? So I'm just closing this and you are back here. If you want to see the head of the data, head means first 6 values. So you can see the first 6 values. And if you want to give the tail command, then you will see the last 6 values, right? Now this command, which is called attach data. Otherwise, what you have to do, you have to extract variables from time to time, because you see age is not a separate variable here. It is in the data frame. It is in the data frame, right? Age is not a separate variable. You need to extract all the variables. So mutation, age, locality, sex, if you want that they should be one by one extractable, then use this command, which is called attach data, or you can use with $. So there is another command, but if you use attach data, then they are easily, you can access any one of them, right? So attach data means it is saying that it has been unmasked and the values are there. So if you want to compute now mean age, you can compute. So this is the mean age, and we have given the command with head. If you give head data, it will give you 6. Let's say I want first 3 only, so put n is equal to 3. If you want 10, put n is equal to 10. So it will give you first 10 rows. So it will just give you first 3 values, because we have n is equal to 3. And if you want in between, let's say between the values like 3 to 10, then put this 3 to 10 and then comma. That means for all columns, rows 3 to 10 and all columns. This is what it means. So rows 3 to 10, 3 to 10 and all columns. And if I want to replace, let's say sex, we have given 1 as male, 2 as female, but there it is written 1 and 2 only. So I want to replace that. It should come in the textual form. So I can use data $, because which variable? Sex. And again in data, this use square bracket, data $sex is equal to. Whenever we want to assign is equal to 1 means for 1. Whenever sex is equal to 1, replace by male. So give this male. Similarly 2, replace this with female. These are the commands to be used. You can practice. So this is male, this is for female. And if you have head data, you can see 1 is replaced with male and 2 is replaced with female now, right? You can see. Earlier it was 1 and 2. You see, it was 1 and 2. Now I replace 1 with male and 2 with female, and you can see that. Okay. Similarly, if I want to make any correction, any correction, let's say data 3 and 4th. 3 and 4 means third row, fourth column. So this is third row and fourth column. 1, 2, 3. Fourth column is gender. And I want to take, this is a male. Third row and this column is male. I want to replace this by female. Right? So this will be replaced with female. Third row and fourth column. Remember, this is male here. So I can, let's say by mistake, I have written male. It has to be female. Then you can replace. So if you replace and again go through, now earlier it was male, now it's female. So similarly, I want to see how many males or females are there. So table sex. So 1 and 2, it will count. There are 31 9 males and 31 females. Table of locality. Table of locality. How many people belong to rural area? How many people belong to urban area? Table of religion. So religion with 1, 45, 2 with 21, and 4 with this. Only this. And if you want to make a cross tab means how many people belong to male, female, and locality. Then you can have a table, sex, comma, locality. So it will give you a 2 by 2 table. For example, male, how many people belong to rural area? How many male belong to rural area? 24. How many male belong to urban area? 15. How many female belong to rural area? 19. How many female belong to rural area? 12. So this is urban area, sorry, 12. So it's a 2 by 2 table. Similarly, sex and religion table can be made. And generally, whenever we are counting is involved, we compute chi-square. Is there any association between the gender and religion or not? So we can use chi-square test. So if I use chi-square test, so this is the value. This is a p-value. So p-value is coming out to be more than 0.05. The result is non-significant. So this is between sex and religion. Means what? That means there is no association between sex and religion. No association means they are independent. That means the distribution of male and female according to religion is almost equal, almost same. This is what we mean by independence, right? So this is one way of importing the data, doing some little bit of analysis. Another way is, if I simply want to not to go into CSV file, simply want to import, let's say Excel file, then we have to make use of one package which is called XLXS. So you have to install this package. Install.package is this. Same way you can install it. You will not have to convert your file into CSV, but those who are newcomers, I will suggest that first you convert your file to CSV, then it's very easy to import. Excel file, because whenever you are using this package, then you have to look at whether you are importing sheet 1, sheet 2, sheet 3. So there are certain problems. But anyhow, if you use this package, then it will be imported. So it is installing now. Just wait. It has been installed. It has been unpacked. And then take it to the library. And there is again, with the same file name, I have an Excel file, but it is in sheet 1, because in Excel you can have different sheets. Sheet 1, sheet 2, sheet 3. But R will import one sheet at a time. If your data is in sheet 2, you can, if it is in sheet 3, you can write sheet 3. So our data is in sheet 1. So you have to write down sheet index 1. And instead of read.csv, now you have to use read.xls and give the extension. So data will come to this file, right? So let's run this. So data has been gone into this file. And if you want to see the first 6, it's the same data file. That was CSV. This is Excel file and same tail. So this is another way of reading the data. Either you can use the same Excel file or you can convert this to CSV first and then read. And there is yet another way, and that is very simple. Another way is import the data set from, you can import from here. There is an import button here, import data set. You see, right? So there is a library which is called read Excel. So it will read Excel file automatically. Again, the same Excel file. But what you need to do, please remember, you go to import data set here, and from Excel, you can import from SPSS, you can import from SAS, you can import from SAS, Stata. You can import from anywhere. Let's say I import from Excel. Then this will appear. Okay. then it is saying where is your file. You browse. Our file is on this Shanti 2. This is on desktop, and Excel file is our test1 file. This is an Excel file, right? I click onto this, open. So it says this is test1, and now file will also appear here. File will also appear here, right? The code has already been generated. You see, the code has already been generated. What I did actually, I copy this. I just copy here, and then I just paste this code here. You can see this code is here. I just paste this here. You can see it's the same code. Compare. It's library, test1 read.excel, test1, and view this. It's the same code. Or you can simply write down import. It will import. Your data will be imported automatically, right? So this is what you can try. So now if I give this, it's the same code has been generated, and it will again read the same file. So there are many ways to read the file into R. I have explained you many ways. Even you can import your SPSS file. So how to import SPSS file? Go to data, from SPSS, and now we have one SPSS file here. For example, this file, age_sex is an SPSS file. This, you see, can you read this? SPSS statistics data document, right? So click onto this. I'll import this file. Press OK. Now the code has appeared, you see, and the file has also appeared. Age, sex, age code. And then you copy from here and paste it here in your program and run that program. Then SPSS file will be imported. Or you can simply press import. You will get the result, right? So cancel here. So this is from SPSS. So this is from SPSS. Run this. So age, sex, now the file is here. You see age, sex, and this. So file has so there are many ways to read the data. Okay. Now with this background, I will go for discriminant analysis. I have already explained you discriminant analysis. So for that, we need a library which is called mass. So I will run this mass. It will go to the library, right? And then there is one file which is called discriminant.csv. So I'm just reading that file. I will show you which type of file it is. So just giving the name data2, you can give any name. So this will be created as a data frame, and this will contain columns of this file, right? So data2, now head data2, I want to see. It is the same file which I explain you, resort visit, then family income, attitudes towards travel, family vacation, household size, age of the head of the household, right? So all these have been in data2. Okay. Then attach data2 means each and every column will be extracted automatically. And if you want to see the view, this is the view. It's the same file I have shown you in my PPT. Resort visit, either people go for resort visit. If they are going, 1. If they are not going, then it is 2. Then it depends upon, this is your dependent variable. It depends upon family income, attitude toward travel, family vacation, household size, age of the household, amount spent, right? So I'm just closing this, and here is this. Now, what to do? We have to run discriminant analysis, and discriminant analysis is basically based on a code. So this is one line code only. So this is called discriminant, and LDA. LDA is used for, just like we use skewness X, kurtosis X. LDA stands for linear discriminant analysis. LDA stands for linear discriminant analysis. All right. So give the command LDA that we want to perform linear discriminant analysis. In bracket, you have to specify dependent and independent variables and your data set. So what is our dependent variable? You see from here, you can see easily. Our dependent variable is resort_v. So I have written resort_v. Then whatever our independent variables, family income, attitude travel, 1, 2, 3, 4, 5. These are 5 variables. Family income, attitude travel, family vacation, household size, age. And our data is in data2. Our data is in data 2. So I have given the complete command. You see, dependent variable, and then this tilde sign, and then all independent variables, and along with the data set. That's all. So it will give you, it will run the discriminant analysis and give you a discriminant function basically. So click onto this. So basically it has run the discriminant, and if I want to see, you can see the entire analysis has appeared. You see, first is prior probabilities. Why probability is 50-50, 50%, 50%, means that there are 15 those who opted for resort visit and 15 observation they have not opted for resort visit. So that's why prior probabilities is 50-50%, right? I mean 50% cases of one, you can read like this. Then these are group means. What is the family income of group 1? That means those who are going for resort visit. Of 2 which are not going for resort visit. So family income of 1 is higher than this. Attitude to higher, here it is slightly higher. Here again it is higher, here it is higher. So age is again higher here, here it is low, right? And based on this, you have developed a discriminant function. This is your discriminant function, please. This is your discriminant function, DS. So your DS is equal to this plus this plus this into family income, this into attitude toward travel, and so on, right? Now, if you want to predict based on what? See what is there in the first column. If you remember, in the first column, there is a resort visit. Either people will go or they will not go. If they go, 1. If they don't go, 2. But our actual data is not that. Actual data is independent variables. And independent variables start from column number 2, not from column number 1. Column number 2, like family income. This is column number 2. This is column 3, column 4, column 5, column 6. So 2, 3, 4, 5, this, right? So now, so there are 5 columns here. So discriminant P. P means how you can predict. So this is a predict based on discriminant, based on this discriminant function. We have to predict data is equal to data 2, and which columns to be used? These columns to be used. These columns to be used, right? And class means whether they are going for a resort visit, not going for a resort visit. Based on that, prediction will be made. So click this. So you are now here and discriminant P. So you can see the first person, which has to be under 1, but it has gone to 2. So there are certain problems, but we will see, rather than looking at this thing, we'll see how well our model fits through the data. How well our model fits through the data. So entire description is here. So determine how well the model fits data. Now in actual data is that it says that 15 are going for resort visit and 15 are not going for resort visit. And they are in which column? They are in column number 1, right? This is already given. And whatever you have, that your prediction case is here. These are all predicted by that. First is going to not to opt for resort visit. Second one is opt for resort visit. Third case, and so on, right? All the 30 cases are here. So this is based on your model. And then we have the actual value. Where is the actual value? In data 2, in column number 1. So you want to match 2. So make a table. Let's call that table as table 1. Table of this, which is predicted by your model. And this is the actual data. They will match with each other. So let's run this. And now if you press this tab, you will get this thing. See what happens here. This is predicted by the model. This is the actual data. In actual data, there were 15 under 1 and 15 under 2. But based on your model, how many have been correctly classified? You see, in actual resort visit, out of the 15, 12 have been correctly classified, right? Because 1 should be under 1, 2 should be under 2, if your model is correct. But what is happening here? It's happening slightly different. Three cases have been misclassified. 3 cases have been misclassified, and they have to be under 1, but they are under 2, right? So it says that there is a not a very big problem. So if in all and all, if you see the out of the 30, how many have been correctly classified? Diagonals are means correctly classified. So 15 plus 12, 27. So out of 30, 27 have been correctly classified, which is a very good prediction, not bad. And if you want to see the accuracy means you take the sum of the diagonal. This is the command. Sum diagonal means diagonal of this. Divide by the total sum. Total sum will be 30 actually. Multiply by 100. You will see the accuracy percentage. So if you run, you will see accuracy, and you can see 90% of the cases have been correctly classified. What does this mean? That if some new individual with all these parameters like family income, age of the household size, etc., I'll give you 100 such people, then based on your model, 90% will be correctly classified by this model. This is what it means. 90% of the cases will be correctly classified by this model, right? Hopefully you understood the entire discriminant analysis. I'll take up one more example of discriminant analysis, then we'll move on to cluster analysis. Okay. This is another data set, discriminant analysis for iris data. And I need to install this package, which is called mass. I will attach this. It is already in the library of R. And if you want to see and which are the data files which are already there in R, please give this command. And that command is basically called library, and then put a bracket, and help is equal to data sets. And if you give this command, you will see all the data sets which are there in R. You will see all the data sets which are there in R, right? And one of the data set will be iris. I'm just attaching that. So it will be attached. And let's say store this in data 1. I'm just storing in data 1. So iris data is, if you want to see which kind of data it is, you can see this is the data. It says sepal length, sepal width, petal length, petal width. So there are certain species which have been discriminated based on their length and width, right? And what are the species? One of the species is setosa. Another one is versicolor. That's the second one. Third one is virginica. Is there anyone? So there are 3 species, right? Virginica, then versicolor, and then setosa. So that means it is a multi-group discriminant analysis. That was a 2-group discriminant analysis earlier, resort visit or not resort visit, 2-group. Now it's a multi-group, and we'll perform the analysis for multi-group also, right? So this is, hopefully you understood, this is your dependent variable. Can we discriminate the species based on these parameters or not, based on length and width? This is what it means. The entire problem is, can we distinguish between the species based on their length or width, right? And for that we apply discriminant analysis. Okay, I'm just closing the file. You have seen already the file. Okay, so if we want to see the first 10 observations, first 6 observations, they are here. Sepal length, sepal width, petal length, petal width, and they are species. Okay, then again use the same discriminant function which I have used earlier. So here is the discriminant function, LDA, linear discriminant analysis, dependent variable. What is a dependent variable? Species. If you are using capital S, I am using capital S. If you use small s, use small s. Otherwise there will be error, right? Then same, I'm using here all capital here. First letter is capital. So first letter is capital. I just copy paste from here actually, so that there is no mismatch, right? This is what I did. I copy from here, Control C and Control V, then plus Control C and Control V. This is what I did. Hopefully you understood this part. And our data is data 1. Data is in data 1. So run this. So, and you get the discriminant analysis result, the same result. Now in this case, there are 3 groups now. Setosa, versicolor, and virginica. So two discriminant functions will appear. This is a first discriminant function. This is a second discriminant function. But first discriminant function is very important. It is explaining 99.12. That means on the basis of first discriminant function, 99.12% of the cases can be discriminated. while second discriminant function is very, very poor, which is 0.0088. So first one is the most important, right? And now our last column. What is our last column actually? If you see, the last column is your species. Last column is your species, if you see. Last column. So in order to make prediction, we have to make prediction about this. We have to leave the last one. We have to take only 4. 1, 2, 3, and 4. So I'm taking only 4. 1, 2, 3, and 4. And the same command, predict. So this will give you a prediction. Discriminant. That means how many cases have been correctly classified. It will give you the idea. New data and data 1 and all the 4s for prediction. Run this and then you can see the result. So this is the result. For example, let's say from here to here. This is all Setosa. That means first 50 observations has gone to Setosa. Next, they have gone to versicolor. And few of them have gone to Virginica from our model. And I want to see, check, what is the correct classification? So one, this is predicted by our model. Then you have actual values also. And actual values, they are in column number 5. Remember, last column. So I'm using this table. Again, tab 1, table, discriminant function, data is equal to data 1. Again, column number 5. Because 5th column contains the species. And it will give you where is the mismatch. Run this command. So it has run. And now look at the table. You see. So 50 has gone to Setosa. 48. Actually, in each there were 50. 150 overall. In each there were 50. But in first case, all the 50 have been correctly classified. Setosa has been correctly classified. But what about versicolor? In versicolor, there were 50, but 48 have been correctly classified and 2 have been misclassified. And Virginica, again, it was having 50 because diagonal you have to see. 49 have been correctly classified by your model. 1 has been misclassified. And now you can look at the accuracy of your model. Accuracy means sum of the diagonals divided by the entire sum. And if you look at this, so accuracy of the model you can compute. It is 98%, which is very, very important, right? So this is called the discriminant analysis. So 98% of the cases have been correctly classified. So I'm done with the discriminant analysis. If you have any question, please, you can ask me. Now I will move on to cluster analysis. Yes, please, any question in discriminant analysis? Any question in discriminant analysis? Any participant? I'll send you this code. You just have to replace this with your file and these commands are same. Hello. Any question, please? Any question? Yes, please. Any participant want to ask something? Okay. I don't think there is any question then. So I'll move on to now, what do you call cluster analysis? You see, we are just going through one RStudio, right? This is the package we are using, RStudio. But there are many other packages where you can perform discriminant analysis, cluster analysis, like it is available in MATLAB also, Minitab, Statistica, FPinfo. This one is basically for sample size calculation and query. You can use SAS, you can use RStudio, Mathematica, Stratigraphics, BMDP is called biomedical data processing. Stata is another package. Systat, S+. So all these packages are used for various statistical calculations. And Python covers all of them, basically. And then these are some of the references. If you want to master your techniques through linear statistical models, you can go through this book by Bowerman. For categorical data analysis, there is an important book by Ellen Agresti. Then for non-parametric statistics, there is a book by Wayne W. Daniel. For biostatistics, there is a book by Wayne W. Daniel. For marketing research, And techniques like cluster analysis, factor analysis, discriminant analysis, multi-dimensional scaling, conjoint analysis, correspondence analysis. This book is very good, Marketing Research by Naresh K. Malhotra. And those who are into biological sciences, medical sciences, they can go through my book also. I have written a book on medical statistics. This is Medical Statistics by Suresh K. Sharma. Okay. So let's move on to cluster analysis now. Now, what do you mean by cluster analysis? Cluster analysis is basically concerned with how you can combine the group of subjects or items based on their similar properties. Let me just repeat. How cluster analysis basically means how you can combine the subjects or objects based on their similar characteristics. And if you able to combine them into based on their similar characteristics, that form a cluster, right? And if they have similar properties, they will go to one cluster. If they have different, they will go to another cluster. If they have different than these two, then they will go form another cluster, right? I'll give you a very simple example of clustering. Let's say in my class, there are 50 students, suppose, and I'm taking class from 12 to 1, and 1 o'clock is the lunch time. When there is a lunch time, you can see the 6-7 girls, they move together in one cluster and they are taking their lunch together. Then 6-7 boys or 8 boys, they are moving in another direction. They are like taking their lunch together, right? And there are 3-4 girls and 3-4 boys, they are moving together. They are taking their lunch together. Why? Because they like each other. They like their habits. Clusters. They are forming basically clusters, right? So this is one example of cluster. The question is how to make clusters out of the data. How to make clusters out of the data. In case of regression analysis, in case of discriminant analysis, there is a concept of dependent and independent, that this is dependent and this is independent. But in cluster analysis, even in factor analysis, there is no concept of dependent and independence. There is no concept of dependent or independent variables, right? Based on the data, there are certain clustering techniques like hierarchical clustering, non-hierarchical clustering, and based on those clustering techniques, the data are clustered, that these items will go to this cluster, these will go to this cluster, these will go to this cluster, right? Okay, let's go through some theoretical background and then I'll give you the practical. So these two people have joined their hands together, they like each other, and then there is a third person. And if this person is having a similar habit, then they will be joined with this. Otherwise, it will go to another cluster. This is just diagram is basically representation of that. So what is cluster analysis? Let me go through. Cluster analysis is a class of techniques used to classify objects or cases into relatively homogeneous groups. Homogeneous groups means they like each other, similar habits. Homogeneous groups called clusters, right? Objects in each cluster tend to be similar, but they will be dissimilar to the other clusters. Both cluster analysis and discriminant analysis are concerned with the classification. Remember, already explained, both cluster analysis and discriminant analysis are concerned with classification. However, in case of discriminant analysis, you need a prior knowledge that initially this was in this and this was in this. That means it was opting for a short visit, it was not opting for a short visit. Or this is a setosa, 3 categories of setosa. Initial categories are required, but it is not required in cluster analysis. There is no prior information in cluster analysis. The groups are made based on the data and certain techniques, right? So this is a very ideal clustering situation. You see, there is a quality variable, there is a price variable. These items, if you see, they are low on quality, but high on price. You can see this scale is higher, this is low. So they are low on quality, high on price. But what about this thing? This is medium on quality, medium on price. These items, high on quality, but low on price. And what about this? This is high on price and high on quality. So very ideal clustering situation. You can easily make clusters out of such type of data. very easily. But the real life situation is something different. Look at the practical situation. This is a practical clustering situation, right? There are now today we will make clusters out of such type of data. We will make clusters out of such type of data, right? Now, two important questions in clustering. How many clusters can be made? Can I made only 2 clusters? Let's say this is one cluster, and let's say this is one cluster. Or can I make 3 clusters? 1 cluster from here, 1 cluster from here, 1 cluster from here. Or can I make 4 clusters? Can I make 5 clusters? That's the first question. How many clusters are possible? Now, to get an idea about how many clusters can be made in your data, the technique is called hierarchical clustering. Please note down, if I want to see how many clusters can be made out of data, the technique is called hierarchical clustering. It will draw a graph. That graph is called a dendrogram. And based on dendrogram, you will come to know how many clusters are possible out of this data. 2 clusters, 3 clusters. So it will roughly give you an idea how many clusters can be made. Once you have the idea, and that is called K. So K is known to you from hierarchical clustering. Then the second type of clustering is called non-hierarchical clustering. And non-hierarchical clustering is sometimes also called K-means clustering. Non-hierarchical and K-means. K-means means if you know K, then you can use this. I know K now from hierarchical clustering. So from K, if you know the number K, that how many clusters are possible, then K is known to you, then you can use the non-hierarchical clustering and put the value of K there. And you will get the exact that this item has gone to this cluster, this item has gone to this cluster, this has gone to this cluster. And you will get the clear picture. So we use hierarchical clustering to obtain how many approximate numbers of clusters are possible. And once we have the approximate idea, then we put this into the non-hierarchical clustering, which is called K-means clustering. And we get the clear description that this item is in this cluster, this is in this cluster. All right. That is the entire clustering procedure. Now, question is, what is this hierarchical clustering? What is this hierarchical clustering? I will not go into mathematics because tough in clustering analysis, but it is based on a distance which is called Euclidean distance. Euclidean distance. And we use 3 types of principles. One is called the average linkage method. Sometimes we use the centroid linkage method, right? And also we use what is called the Wahl's method. So if you're using SPSS, then Wahl's method is best. If you're using R, sometimes the average method or the centroid method, both of them are equally good, right? Okay. Now, what is this Euclidean distance? Let's say I take these 3 items are very, very close. These 3 items. Let's say I look at the center. These 3 items are very close. So based on 3 items, their values will be there. I compute the mean. Mean will be somewhere here. That will give me the roughly the one center. And that is called cluster center, right? So based on, let's say, these 3 items, which are very, very close, I able to compute the mean, and that is called cluster center, say C1, right? Now, once you have C1, then it looks into the distance of C1 from other items. Distance of this from here, distance of this item from here, and combine that item, which is very close to the center, into this cluster. So 3 items are already in this cluster with one centroid, and then it looks into the distance. Now, what is this distance? Suppose there are 2 points. Let's say point P1, whose points are x1, y1, and there is a point P2 whose coordinates are x2, y2. And what is the distance between P1 and P2? So this is nothing but under root of x1 minus x2 square plus y1 minus y2 square. This is the formula to compute Euclidean distance. So it computes the Euclidean distance of 2 points and combine those items which are close, which are having close distances. it go on combining. Let's say this item is very close, it will go to this cluster. This item is very close, again go to this cluster. This item is again close, go to this cluster. But what about this one? This item is far away then. If this item is far away, then there is a threshold. Threshold will be computed. Let's say I combined 6-7 items in one cluster and they were within that threshold. And when I started combining the next one, then it has crossed that threshold. If it has crossed the threshold, like this point, then it will put into another cluster. It will put into another cluster, right? So distances will be computed. Again, one centroid will be taken. One centroid will be taken, right? And then procedure will be repeated. So if all the items are close to that centroid, they will be combined in that cluster. Once it crosses again the threshold, then it will go to the next cluster, and so on. This is how the technique goes. And this technique is called basically hierarchical clustering. When we combine these 3 items, there will be one cluster center. When the 4th item will also be combined, then the cluster center will be modified. That means it will be based on 4 items. When the 5th one is there, it will be again modified. And it will go on modifying till all the items are consumed in this particular cluster and they are within the particular threshold. If they crosses, it will go to the next cluster. Same procedure will be followed. And this technique is basically called hierarchical clustering. Okay? All right. So some statistics associated with the cluster analysis. One of them is called agglomerative schedule. Agglomerative schedule means hierarchical clustering basically. And agglomerative schedule gives information on these subjects or cases which are being combined at each stage. At first stage, how many can be combined? At second stage, how many can be combined? And it is a hierarchical clustering process. Then cluster center, I have already explained. Then cluster centroid, right? It is arbitrarily taken first and then modified from time to time. Then cluster membership means whether this item will go to this cluster or this cluster. Then dendrogram. Dendrogram is a very, very clear picture that will give you an idea. You have to look for gaps in dendrogram. And that will give you that these items, out of this, how many clusters are possible. So dendrogram will give you a complete idea. It's a graph that how many clusters are possible in your data. I will show you the dendrogram. Then the distance between cluster centers, if they are close, no problem. But if they are quite apart, they will go to different clusters. Then this is not a very good diagram. I'll just skip this part. Similarity matrix will be there. That means which pairs are closer to each other. Coefficient matrix will be there. And conducting cluster analysis. Right. So first of all, we will apply hierarchical clustering procedure. And once the K is known, then we'll go for the non-hierarchical procedure. Okay. So it is based on a Euclidean distance. So Euclidean distance between 2 points. One point is x1, y1. Another point is x2, y2. Euclidean distance will be under root of x1 minus x2 square plus y1 minus y2 square. So computes all the distances and combine those items which are having smaller distance and go on combining till it crosses threshold, right? So that is the procedure. So in cluster analysis, there are 2 types of procedures. One is called hierarchical clustering. Another is called non-hierarchical clustering. And if you use hierarchical clustering, we use agglomerative schedule, which we will be using. And it is based on 2 types of methods, 3 types of methods, either linkage method, variance method, centroid method. In R, generally we use average method.
You are not audible.
Not audible? How long?
No, sir.
Is it audible now?
Yes,
Yes, it is audible.
Hello.
sir.
Am I audible?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Am I audible now?
Yes, sir. Yes, sir.
Yes, sir.
Let me see. I think the signal is complete.
नहीं ठीक है sir. कोई problem नहीं. Continue.
There is no connectivity issue.
नहीं
Can you listen to me, please? Hello.
Yes, sir.
Yes, sir. Yes,
Am
sir.
I audible?
Yes,
Yes,
sir.
Hello.
Yes, sir.
Yes, sir.
Yes, sir. आ रही है आवाज.
Yes, sir, you're
Krishna,
audible.
can you listen to me, please?
Yes, sir. Yes, sir. Very well. Sir.
Just a minute. Let me check the connection. सुशांत देखना नेटवर्क चल रहा है क्या?
किसको आवाज नहीं आ रही थी? किसका प्रॉब्लम हो रहा था ऑडियो?
हेलो,
हाँ सर।
am I audible now?
यस सर।
सर आवाज आ रही है आपकी? सर मुझे फोन कर रहे हैं।
हेलो,
हाँ सर आपकी आवाज आ रही है।
नहीं आ रही है?
नहीं आ रही है सर। सभी सब
मैं तो रिस्पांस पूछ रहा हूँ, आप बोलिए उधर से। मेरे को तो आपकी आवाज नहीं आ रही, आप बोलिए।
हाँ सर
जी सर, आ रही है सर
आ
आवाज।
रही है सर। सब
आपकी तो आ रही है, लेकिन आपकी आवाज मेरे तक नहीं आ रही है, वहां से नहीं आ रही है।
तो देखिए सर,
नेटवर्क एरर है सर, नेटवर्क प्रॉब्लम है सर आपको।
हो सकता है।
नेटवर्क कहीं होगा प्रॉब्लम। मैं ऐसे करता हूँ, मैं दोबारा ज्वाइन कर लूँ 1 मिनट में।
जी सर, जी सर।
यस
मैं दोबारा ज्वाइन कर लेता हूँ, सो दैट देयर शुड नॉट बी एनी इशू।
हाँ सर।
ओके। Am I audible now?
Yes,
Yes,
sir.
sir.
Okay, sorry. I think there was some network issue, but
Yes,
anyhow.
Okay, sir.
Okay, sir.
So we were here. How have you missed something or the previous slide also? Or that was okay.
No, sir. Actually, nothing we have missed. We are just listening you very clearly.
Okay. So we were here actually. I was discussing about that clustering. There are 2 types of clustering procedures: hierarchical and non-hierarchical clustering. And we will be using hierarchical clustering first. From using hierarchical clustering, you will come to know about how many clusters can be made. One thing, and then we will put that number in non-hierarchical clustering, and we will get the exact that this item goes to this cluster, this will go to this cluster. And in R, generally either complete method is used or average method is used. So I will be completing both and compare them also, that by using complete method this is the result, by using average method this is the result. Both of them are equally good, right? Okay, so here is the next one is the data set. I'll show you the data set. For example, these are the cases actually, attitudinal data from clustering.
So you have not shared the screen.
Oh, yes, I have not shared the screen. You are right. Absolutely right. Let me share the screen. Is it visible now?
Yes, your screen is visible, but the presentation is not. But your screen is visible.
Yeah. Presentation I'll open. I'm just open.
Okay.
Just wait. Now the PPT is okay. Can you see the PPT?
It's okay. Yes, sir.
Yeah. So we were here actually. All right. You see, first of all, this is the data with me of about 20 customers. Whenever people go to the mall, they focus on many things, right? And let's say we want to combine them. Some of them are brand conscious, some are price conscious, and their behavior have been captured in terms of 6 variables. This is variable number 1, variable number 2, variable number 3, 4, 5, and 6. And they have been measured on 7-point scale, right? For example, shopping is a fun. For some people it may be, some people it may be very bad. If it is bad, they give this as number 1. If it is a fun for them, they may be liking it number 7, and so on. So all their behaviors have been captured in the 6. Question is, we will make clusters out of this data. So 2 important questions: how many clusters can be made, and there are 20 customers. You can put them name also, name number 1, 2, 3, 20. These are 20 in number actually. So I want to see that out of these 20 customers, which customers are having similar habits, which are having another similar habits, which are having another similar habits. If there are 3 clusters, if there are 4 clusters, then which can be put into different clusters. That is the idea of this. So what it does actually, it will compute, it will give you a distances. Actually distances will be in this format. For example, first customer number 14 and customer number 16, their distance coefficient here means distance. Their distance is very, very small. You see how to read this table is here like this. So 14 and 16, their distance, this coefficient means distance, right? Euclidean distance. So this is the distance, very, very small, 1 only, right? And if it is 1, you can see first customer number 14 and 16 will be combined. This is what it means. Then in this table, you go to the next step. What is the next stage? Next stage is 6. And straight away, you will not go through the second step now. Go through number 6. 6 is here. And in 6, out of 14 or 16, one of the number will appear. And see which one has appeared. In 6, next stage, 14 has appeared. That means next item that will be clubbed with this cluster will be number 10. So first 14 and 16 will be clubbed. Then next stage 6, go to 6. One of the number of 14 and 16 will appear. Next will be 10. So in how many items will be clubbed now? 14, 16 and 10. And then you read table like this. It goes to next step. Next stage is 9. You straight away move to 9. And in 9, out of 10 and 14, one of the number will appear. Which number is appearing? 10 is appearing. So next item that will be combined will be 4. So this is how this table has to be read, right? So first 14, 16, then 10, and then 4. And next will be 12. You move on to 12. Out of 4 and 12, 4 and 10, one of the number will appear. 4 is appearing. So 19 will be the next one. So this is how the combination process will go. And based on these distances, you will get a picture of the dendrogram. So this is the dendrogram. You see, first we have combined 14, then 16, then 10, and then 4 and 19. I have already shown you. And look for the gaps in dendrogram. This is called dendrogram. So this is one gap here, one gap. This is another gap here. So basically, one cluster from here, another cluster from here, another cluster from here, right? So basically, 3 clusters can be made out of this data. So look for the gaps actually. So one gap, second gap. If there are 2 gaps, there will be 3 clusters. If there would have been 3 gaps, then there would have been 4 clusters. So dendrogram will give you a rough idea about how many clusters can be formed. So idea here is that 3 clusters can be formed. So we get K. And then we put this value of K into our known hierarchical clustering procedure, either using center method or average method, right? And we will get the result that this item goes to this cluster, this item will go to this cluster. All right. But how the items, I mean, which customers having similar habit? 14, 16, 10, 4, 19, and 18. So all these are there having similar habits. This is the classification. 2, 13, 5, 11, 9, and 20 customers, the numbers with this name. You can put the name there. So these names will be having the similar habits, and these will be having the similar habits. So you can make clusters out of this data. So I'm going for a practical now and show you that there will be 3 clusters and all distances will appear and everything will appear. So I'm going for clustering procedure now. Okay, just minimizing. Can you see the screen now?
Yes, sir.
Okay.
Yes, sir.
All right.
Yes, sir.
All right. Okay. Okay. So let me go through the clustering procedure. So this is a cluster analysis of shopping malls. People go to mall, they want to buy different things, right? Okay. So it's the same data and we will make clusters out of this data. First of all, I'm reading this data. It is a CSV file in my Shanti2 folder. So there is no need to give any path, just read the file. So I'm reading the file. So file is in data 3. And if you want to see the data, you can run this command. So this is the data. See, it has been the entire analysis based on 7-point scale. And for example, shopping is a fun. For first customer, shopping is a fun. I mean, little bit. For example, number 3, it says, yes, it is fun for me. Maybe he's having a lot of money. But look at customer number 5. It gives number 1. That means it is not good for me. Shopping is bad for budget. Second variable. People combine shopping while eating also. I mean, whenever they go to the mall, they want to take their dinner or lunch outside same day, right? So how they prefer, their preferences. Then you can get the best buys by shopping. I mean, go through the brands and all these things. You can compare prices in different showrooms and then go for, right? So these are all 6-7 variables, and we want to make clusters. And there are how many customers? 20 customers. And we want to combine which customers are having similar habits. That is the whole idea, right? Okay, so we have viewed the data and just closing this data, and we'll make clusters. So first go for hierarchical clustering. So this is just the structure. It's a data frame, 20 observations, 6 variables. And these are the first 6 observations. If you have attached this data so that you can extract. Now, what is our first aim? Our first aim is to compute Euclidean distances. Euclidean distances between the points. And we want to combine which are having smaller distances, right? So that I'm writing as D. D means distance. Find distance matrix. Our data is in data 3. So simply you have to write down one command, distance, dist, data 3. And all the distances will be computed. Let's see. So it has computed now, and they are stored in D. And if you want to see D, you see all the distances are here. You see all the distances. You can see, for example, from first item, from second item, the distance is 8. First item from third item, distance is 2. First item and fifth item, the distance is 8, and so on. But it is difficult to read this table. So let me just reduce the decimals. There are 6-7 decimals. If you want to reduce the decimal to 3 decimals, so 3 digits, then you can use print D with only 3 digits. So run this command. Now it is readable, slightly readable now, better. So it will combine first of them. If you remember, 14 and 16. So 14 is here and 16 from here. 14 is the last one and 16 from here. You see this distance 1.41. This is the smallest one. Out of all this, if you see the distances, because I have seen this from the dendrogram. Dendrogram says that 14 and 16, they were clubbed first. 14 from here, right? And 16 from here. If you see 16. This distance is 1.41, the smallest one. So they will be combined first. They will be combined first, right? And so all the distances have been computed now. And then we go for hierarchical clustering with complete linkage method. And for that, I am using hierarchical clustering, giving the name HC. HC means hierarchical clustering. Dot C means complete linkage method. Then command that how to make clusters is called HClust. HClust means hierarchical clustering of distances. Hierarchical clustering of distances. Distances we have already computed. So I'll go for this, run this command. So because I have to draw the graph now, let me go through the plot. It will give you a plot which is called dendrogram. Very clear picture will be there. All right. So hierarchical clustering distances have been. Now I want to make this. So print is already there. Now you want to make hierarchical clustering based on this. So method has complete by using the which method? Complete linkage method. Now I want to plot, and this plot will be for plot of the dendrogram. Plot, our entire distances are here. HC.C. Plot this. And if you plot this, you will see dendrogram, right? If you see the dendrogram, if you can zoom this dendrogram also. From here, if you see the zoom picture, and you can clearly see how many clusters are there. You see, this is one cluster. This is another cluster. This is another cluster. You can see 3 clusters can be made out of this data. I have already shown you that table, that the distances of table, that 14 and 16, 4, 10, 19, 18, they were combined into one cluster. You can see here also using complete method, right? Okay. So basically we get the idea that 3 clusters can be made out of this data. So number K is now 3, right? And you can, if this, sometimes this picture is not very clear, then you can use hang 1, hang -1. Hang means it will give you the same picture, but not with another representation. So if I run this, your representation will look like this. This is called hanging picture, right? So it will look like this. So 3 clusters are visible clearly. This is by using complete linkage procedure. Now, same thing you can get it by average linkage method. By default, R will give you with this command the complete linkage method, but you can try with other method which is called average. So for that, I'm just using hierarchical clustering. Dot A means average, then HC cluster of the distances, same distances, but method will be average. Method will be average, and then you complete this. Now everything is here, and then again plot. If you plot, then again 3 clusters, but here you see 10 and item first combined. In earlier version, we were combining 10 and I think 4 first, but picture is almost same, that there are 3 clusters. We want to get, if you get the hanged one, then you can run, and there are again 3 clusters. Now our K is known to you. What is our K now? Number of clusters 3, right? Then we can go for non-hierarchical clustering. And in non-hierarchical clustering, you have to put that number. Non-hierarchical clustering is also called K-means clustering. So your results will get from the non-hierarchical clustering. Results will be equal to K-means means non-hierarchical clustering. Data is data 3. Data is our data 3 and 3. 3 means because our dendrogram says that there are 3 clusters. It will ask you, otherwise it will not run. You have to find out K first from dendrogram. So now run this command. So it has run, and if you want to see the results, you can see all the results are here. That first item has gone to cluster number 2. Second item has gone to cluster number 3. Third one has gone to cluster number 2 again. And then this has gone to cluster number, and all the items are here. All the 20 items are here. Which item has gone to which cluster? If you have given the name of the person, then the first person has gone to second cluster. Then 2 you can pick up. Then all which are representing 2, all the names you can pick up. Those people are having similar clusters basically. So certain attributes are there. You can look at the size of the cluster. You can look at the cluster centers. Different things can be looked into. For example, if I'm interested into size of the cluster, so run this results $sign size. So first is having 6 customers, second cluster is having 8 customers, and third one is having 6. And what are this 6? You can count from here. In one there will be 6. 1, 2, 3, 4, 5, 6. So these are the 6 people who are having similar habits. And in 2 there will be 8. You can count. And in 3 there will be again 6. So out of the 20, 6 have gone to cluster number 1, 8 have gone to cluster number 2, 6 have gone to cluster number 3. So these are all clusters. And you can look for cluster centers also, which is not required in fact. So these are all cluster centers. So now, so this is based on the results. If you want to compare, you can also compare the 2, average cluster method and the centroid method, which is called this is called by complete linkage method. If you want to compare by complete linkage method, is there any discrepancy between the 2 methods or not? So you can use this, cut into 3 clusters, and then compare. So let me do this also. Run this. This is by using complete linkage. This is by using average linkage, and you want to compare by using that 8 in first, 6 in this, 6 in this. There is no mismatch. So either you use complete linkage method or you use the average linkage method, the results are almost similar for this data, right? And here is the cluster centers based on this. So these are the cluster sizes. So that is all about the cluster analysis. If you have any questions, please, you can ask me. Any question, please, in cluster analysis. Yes, please. Any question in cluster analysis, because today's session is over now and you have to just ask the questions if you have any question.